In this video, I will teach you how to multiply rational expressions. So there are no restrictions whether they are similar or dissimilar. So what we're going to do here is, since we're given with monomials only, we try to simplify each of them by looking at the numerators and in the denominators. So since this is multiplication, we can eliminate or cancel out the numerator here with the denominator here, the numerator here with the denominator here, since we are multiplying them. Okay, so let's start with the numerical coefficients. So here we have 21. So look at the denominators here. So which among them can have or can be eliminated or can have a common factor with 21? So that is 7. So if I look for the GCF of 21 and 7, that will be 7. So if I divide 21 by 7, that will be 3. 7 divided by 7, that will be 1. So cancelled out already. So look for 12 and 8. So is there a greatest common factor between 12 and 8? Yes. I can divide 12 and 8 by 4 because 4 is their GCF. So 12 divided by 4, that will be 3. 8 divided by 4, that will be 2. Then look at the variables. So those with the same variables can be simplified. So x to the 4th, then x squared. So since I have here to the 4th power, 4 minus 2, that will be 2, or x squared. So I will put x squared here on this part because 4 is bigger than 2. Whereas in y, I have here to the 1st. So that means 3 minus 1, that will be y squared. So I will put y squared here on this part because 3 is bigger than 1 over there. So for your final answer, 3x squared here times 3. So what we're going to do is to multiply the numbers here. We have here 3 multiplied by 3, that is 9. Then x squared. Over, so look at the remaining terms here in the denominator. I only have 2y squared. So 2y squared. So your final answer is 9x squared over 2y squared. So what about if you're given binomials already? So for example, I have here 2x plus 2 all over x plus 1 multiplied by x plus 2 divided by x plus 1, or over x plus 1. Okay, so it just so happened that the denominators are the same. So it's just okay. So what we're going to do here is to apply factoring methods. So which among them is factorable? So as you can see, your numerator here is factorable. This one is not, this one is not, and this one is not. So you just stay the same. So applying CMF. So why am I applying CMF? Because I can see a common factor between 2x and 2. The common factor between the two is 2. Because I can divide 2x by 2 and 2 by 2. Dividing each term by their GCF, so 2 will be cancelled out, so x is left. 2 divided by 2, that will be 1. All over, so you just copy the remaining terms here, so x plus 1 multiplied by x plus 2 all over x plus 1. So to eliminate this 2, you put pairs of parentheses here. Okay? So do not forget that. So cancelled out. So here you are left with 2, then 1 on this part. Okay, so multiply the factors or the terms here. So 2 times x plus 2. So 2 times x plus 2. Then for your denominator, you only have x plus 1. So as you can see, there are no common terms in the numerator and in the denominator. So you can have this as your final answer, or you distribute this. So it can be 2 times x, 2x, then plus 2 times 2, 4, then x plus 1. So this can be your final answer or this one. Okay? Now, if you're given trinomials, so just like what we did here, we apply the different factoring methods. So let's start with this. X squared plus 6x plus 9 all over x squared plus x minus 6 multiplied by x squared plus 2x plus 1 all over x squared plus 4x plus 3. Okay, so let us check the factoring method that we're going to use in each polynomial. Okay, so here, as you can see, we have a trinomial and your last term is a perfect square. So we can apply PST here. On this part, negative 6 is our last term. So this is not a perfect square. So we can apply GT here, general trinomial. For this part, your last term is a perfect square. So we can have PST. Whereas here, 3 is not a perfect square. So this is considered a general trinomial. So since we have the factoring methods, let us now factor them out. Okay, so applying PST here, so again, we put these symbols. Applying PST in the first numerator, the factors must be twins. So since your middle term is positive, or the sign of in the middle term is plus, so you put plus on both pairs of parentheses. Square root of x squared is x, so you put x here. Square root of 9 is 3. Same goes here, since we are using PST. Since your middle term is positive, we put plus here. Square root of x squared, x here. Square root of 1 is 1. For the denominators, we apply GT. So we put pairs of parentheses. Then factors of x squared, we have x. So since your last term here is negative, we must have a positive number and a negative on this part. Okay? So let us look for factors of negative 6 that when added, it should be positive 1 because your middle term here has a positive 1, a numerical coefficient of positive 1. So we look for factors of negative 6 since that is your last term. So since you have a negative number here, your factors must have different signs. So 1 times negative 6 is negative 6. I can also have a negative 1 and positive 6. Another pair of factors, 2 and negative 3, or negative 2 and positive 3. So which among them can have a sum of positive 1? So let's add this 2. We have negative 5. We solve this. We have positive 5. We solve this. We have negative 1. We solve this. We have positive 1. Our target is to have a positive 1. So we have here minus 2 and plus 3. So since this is plus, I consider 3 here because your 3 here is positive. Then since this is minus, I put 2 here. Now, let us now factor this part or factor out this part. So since everything is positive, therefore here are both plus. Okay, so factors of x squared, we have x. Factors of 3, that when added, we have 4. So factors of positive 3. So both should be negative or positive, but since our target is both positive, we only consider both positive. So 1 and 3. If we add these 2, we have 4. So since positive 4 is our middle term, we take this 2. positive 1 and positive 3. Now, let us check if there are terms that are the same in the numerator and in the denominator. So let's cancel out. We can cancel out this. So you choose which between these two. So you can have this or this one. So let's have this. Another x plus 3 because we have here x plus 3. Then x plus 1 because I have x plus 1. If you already eliminated this with this, you cannot use this with this, okay? So, for your final answer, what is left here in the numerator is x plus 1. And in the denominator, you're only left with x minus 2. So, this is your final answer.